Hello everyone. In this lecture, we will discuss about the Johnson algorithm for sequencing problem with n jobs through two machines. The algorithm, which is used to optimize the total elapsed time for processing n jobs through two machines, is called as Johnson's algorithm and has the following steps. Consider the n jobs. Let us consider 1, 2, 3 up to the n number of jobs processing on two machines, that is the machine A and machine B in the order of AB. The processing time are A1, A2 dash dash up to the AN for the machine A and B1, B2 dash dash up to the BN for the machine B as given in the following table. So here observe that one, the machines having the two machines, that is the machine A and machine B, and jobs are the 1, 2, 3 up to the small n, and here A1, A2, A3 up to the AN is represents the processing time for the jobs 1 to n on the machine A. Similarly, B1, B2, B3 up to the Bn is represent the processing time for the jobs 1 to n on the machine B. The problem is to sequence the jobs so as to minimize the total elapsed time. And let's see the Johnson's algorithm. So first step is select the least processing time occurring in the list of A1, A2 dash AN and B1, B2 dash BN. Let this minimum processing time occurs for a job K. So here first step is we have to select the minimum processing time in the list of the all the processing time of the machine A and machine B. Here let us consider the minimum processing time is occurring for a job K. Let's see the second step. If the shortest processing is for machine A, process the kth job is first and place it in the beginning of the sequence table. See here, if the processing time is minimum is for the kth job on the machine A, then you have to place this kth job in the first of the beginning of the sequence table. If it is for the machine B, process the kth job last and place it at the end of the sequence. See, in the second step, we have to place the kth job. If it is the kth job, that is the minimum processing time on the machine A, then you have to place the first in the sequence table. If it is the kth job is on the machine B, mean we have to place this kth job on the end of the sequence table. Step 3 is when there is a tie in selecting the minimum processing time, then there are maybe three possible solutions are there. First one is the if the equal minimum values occurs for only for machine A, then we have to observe the processing time on the machine B. Then select the job with smaller processing time in B and it is to be placed in the first of the job sequence. Second condition is if the equal minimum values occurs for the only machine B, then we have to observe the processing time for the machine A. Select the job with smaller processing time in A and it to be placed last in the job sequence. Third one is the if there are equal minimum values, one is for each machine. See here in the third one is it to be occurred minimum values two machines, machine A and machine B. Then we have to place the job in the machine A first and the one is machine B last. So next fourth one is delete the jobs already sequenced. So which is we have to place it in the optimal sequence table. The respected job is to be deleted in the given table. If all the jobs have been sequenced, then you have to go to the next step. Otherwise, you have to continuously repeat the steps 1, 2, 3. So step 5 is in this step, determine the overall or total elapsed time and also determine the ideal time for the machine A and B. It is as follows. Here, total elapsed time equal to the time between the starting the first job in the optimal sequence on the machine A and completing the last job in the optimal sequence on the machine B. Next, ideal time on machine A equal to the time when the last job in the optimal sequence is completed on machine B minus time when the last job in the optimal sequence is completed on a machine A. Similarly, ideal time on machine B equal to the when the first job in the optimal sequence starts on the machine B plus it is the summation of the second job, that is the k equal to the 2 to last job, that is we are considering the n number of jobs, so small n. So it is the summation of second job to the last job, that is the k equal to 2 to n summation of time kth job starts on machine B minus time k minus 1th job finished on the machine B. So this is the Johnson's algorithm. So this Johnson's algorithm we will be applying with example problem in the next lecture. So thank you.